Dear students, in this video lecture, we are going to learn about conducting polymers. Generally, we know that polymer materials are insulating material. There is no conduction possible in polymer material, and this is mainly due to the strong covalent bonds. So, generally, polymers consist of very strong covalent bond between the chains, while bonding between the chains are considerably weaker. Along the chain, it has a very strong covalent bond, but between the chains, it is considerably weaker, very similar to a graphite material. If you take a graphite, so along the hexagonal layers, it possesses a very strong covalent bonding, but between layers, it possesses the weak metallic bonding. Very similar is possible in certain polymer materials. So the polymer are insulators due to their wide band gap, low carrier mobility, and low melting point. But using synthetic methods, highly conducting doped polymers such as polyacetylene are developed. Certain polymer material can show some excellent conducting excellent electrical conductivity by having certain dopants. By doping suitably, we can improve its electrical properties. And not all the polymers can exhibit improved electrical behavior. Only certain polymers can exhibit. So one among that is the polyacetylene. So they have defects-free polymer chains and have high electrical conductivity as that of copper. These are all called as doped conjugated polymers. The below list indicates some of the doped conjugated polymers, its conductivity value, and its stability in doped state, and its processing possibilities. Because, as I told, not all the polymers uh, can have a very good conductivity by doping. Only certain has very good conductivity, and the processing ability can also be uh, is possible only with certain material. So, for example, the polyacetylene, it possesses a very good conductivity of 10 power 3 to 10 power 5. However, the stability is very poor and the processing possibilities is also limited. It cannot be processed that much easily. And polyphenylene, its conductivity value is 1000, and the stability is very poor, and the processing possibility is also limited. So PPS, so its conductivity value is 100. The stability is very poor, but it has a very good processing possibilities. And PPV, it possesses value of 1000, poor and limited. Polypyrrole, the value is 100. The conductivity value is very low, but still it possesses very good stability and very good processing possibilities. Polythiophene also possess very good stability and processing power possibility, even though its conductivity value is fairly low. And the least conductivity value is exhibited by polyaniline of 10 ohm inverse centimeter inverse, but its processing possibility and stability is fairly good, but the conductivity value is very low. And this conductivity values can be suitably altered by having the dopants. Suitable dopants can the dopants can be changed, and by changing suitable dopants and doping concentration, it is possible to improve its conductivity value, and also the processing abilities can be altered by going for some composite fibers. And these topics, these materials are there is the under research, and they are scientists, they are trying out different kind of polymer material that can have a very good conductivity value and processing abilities. The main importance of having But polymer material in the field of why the polymer material is required. So even though we have a copper which can have very good electrical conductivity, but still why we need conducting polymers. The main advantage is the polymers are lightweight and polymers are flexible, because the weight wise it is low, and it is more flexible than normal metal, copper metal or any other metal which possess very good electrical behavior. So that could be the main reason why they go for conducting polymers. The next topic is photoresponsive polymers. So these photoresponsive polymers are those which respond to light radiation. As the name indicates, it responds to light radiation. They are also called as optical polymers, and these materials can be used for OLED purpose, light emitting devices. Uh, so light emitting devices can be made up of light emitting polymers, can be made up of this photoresponsive polymers, and in certain places it is also mentioned as semiconducting polymers. So they are used to make light emitting devices, making lenses, fiber and passive thermal optical switching elements. So for such a purpose, to act as a light emitting diode, it is the material is sandwiched between a cathode and anode. It is sandwiched between a cathode and anode. So indium tin oxide is used as anode, and gold or aluminum is preferred as cathode. And this layers can be done either by spin coating or by evaporation techniques. So the aluminum generally is deposited by evaporation technique, and the indium tin oxide is done by spin coating technique. And this will be the diagram shows a typical photoresponsive polymer sandwiched between an anode and cathode, which act as a light emitting device. Where it is connected to a battery power supply, it can potentially emit light radiation just like an LED. How it works in a semiconducting LED. Very similarly, we can form an LED using this photoresponsive polymers. So the next topic is graphene. Graphene, even we can say it is like one allotropic form of carbon. So previously you might have studied in school days about the allotropic form of carbon, graphite, diamond, charcoal, fullerenes. In addition, carbon nanotubes, and nowadays even graphene can also be called as one form of allotropic form of carbon. So graphene is a semi-metal with with a small overlap between the valence and the conduction band. So very small overlap means the band gap is zero, but it doesn't overlap to greater extent. Very small extent. Even one atom thickness in that range. So it was the overlapping is it is or else even we can say that it is a zero band gap material, but the band gap doesn't overlap greatly as that of metals. Generally, for example, metal are very good electrical shows a very good electrical conductivity because of a large overlapping. There is a large number of free electrons will be available, but here there is no such case. So the band gap is zero band gap. The charge carriers are negligibly small, so it possesses zero band gap, but the overlapping just occurs. It is very slight. So it is considered as one of the allotropic form of carbon consisting of single layer of carbon atoms, as the diagram indicates. So it is connected in hexagonal layers, and only one single layer of carbon atoms, we call that as graphene. So it is the basic structural element of other electropies. For example, if you want carbon nanotubes, if we roll this graphene sheet, we can get the carbon nanotube. And in an expanded view, we can say that this is the graphene material, and either it can be rolled to get carbon nanotube, or this can be made as a spherical to form a filtering, etc. So one of the most useful properties of graphene is that zero band gap, okay, zero overlap semi-metal with very high electrical conductivity. So with both holes and electrons as charge carriers. So this is another reason why we say zero band gap, because if you say about normal conducting materials, there the conductivity takes place only due to the free electrons alone, but here free electrons as well as holes both will contribute as charge carrier. That is the reason for saying zero band gap rather than overlapping. So here electrons will be there as well as holes will be there, and both will contribute for electrical conduction. Due to that, it possesses very high electrical conductivity. And one of the outstanding properties of graphene is its inherent strength. It is the strongest material ever discovered, with an ultimate tensile strength of 130 gigapascals. When compared to A36 structural steel and aramid silver, it possesses a very high value, because A36 has a value of some 400 40 gigapascal, and here for aramid fibers it possesses 37.5 gigapascal. And compared to that, it possesses 130 gigapascal. That much very good strength is graphene. So not only extraordinarily strong, it is also lightweight. That is one of the special thing about this graphene material. So there the strength what is given here, it is for the weight wise it is very high weight, but here it is very lightweight when compared to any other material. So for comparison purpose, if you compare that 1 square meter of a paper, the 1 square meter of a paper is roughly 1,000 times heavier than one single such dimension of graphene. So 1 square meter of graphene, it is 0.77 milligrams per square meter. So and comparatively, it is very lightweight. The graphene has an ability to absorb 2.3 percentage of white light, and it is also an unique and interesting property of graphene. So where it can absorb white light absorption will not occur in any kind of material. Only certain materials have that property, and this material possesses a very good white light absorption, and this is mainly due to its electronic properties. It has both electron holes and electrons as charge carriers. The electrons acting like massless charge carriers with very high mobility. That is the reason why this white light absorption is possible. And even this material is under research, and scientists they are trying out many different applications of this graphene material. The next topic we see that in next class.